Welcome to the Core Outdoors Speaker Series. I'm your host, adventure journalist Jamie Moy. Core Outdoors is a collective of gear designers, makers, repair technicians, and manufacturers based here in the mountainous Kootenay region of British Columbia, Canada. Core produces this free webinar once a month to share knowledge and information and and to build relationships. For June, I'm joined by Dana Carpenter and Trevor Young from the Outside Lab in Colorado. The lab is a collaboration between CU Denver's College of Engineering, Design, and Computing and Outside Inc., which is a parent company of Outside Mag. And I feel like my worlds are colliding here because that's the same region of Colorado I moved to, the Kootenays, from some 10 years ago, and I continue to write for Outside Magazine. But enough about me. Hello, Trevor. Hello, Dana. Welcome.
Thank you for having us.
Yeah, thank you.
Yeah, it's great. It's great to have you here. If you guys could go ahead and share your screen, we can get started. And just also wanted to mention we are hoping for a Q&A as well, and we'll definitely leave time for that. So please do bring your questions. Let's just hold them to the end, though. Thanks.
Great. Just to confirm, are we looking at the appropriate screen?
Yes, we are.
Okay, great. So we'll go ahead and get started here. I think it's probably best if we start with some introductions for those of you who may not be familiar with Dana and myself. I'm Trevor Young. I'm the lab manager here at the Outside Lab at CU Denver. Prior to my role here in the lab, I was a PhD student in the engineering department here with Dr. Carpenter as my advisor. My current roles with respect to the lab have ballooned to become essentially anything that needs done within the lab. So that could be your day-to-day testing and data analysis. That might be doing brand outreach, putting together budgets and proposals, and anything else that you can think of. I will likely be your point of contact for those points of interest.
And I'm Dana Carpenter. I'm a professor in mechanical engineering here at CU Denver and technical director for the Outside Lab. So I oversee the lab operations from the university's side, and then just basically help get Trevor whatever he needs to get the lab going and to make some really cool progress in the lab. So thanks a lot for having us today, and we're looking forward to telling you more about what we do.
So with that being said, we wanted to start with a little bit of background as far as where the lab comes from and how we got started. Dana here has been a part of the lab since its initial inception, and I came in a little bit later, so I'll go ahead and let him lead as far as our background and kind of mission statement here.
Yeah, so the kind of the idea for the whole lab was originally initiated by Outside Inc. They were looking for a university partner to create a lab where they could start to do some more objective, repeatable scientific testing to help supplement their amazing gear reviews. So they have pro athletes, expert testers that are doing field testing all the time to really put gear through its paces and give good, thorough reviews. But they wanted some more kind of repeatable scientific objective data to add to that. So that's where the idea started. So we started looking for ways that we could put this together at the university, and then we ended up coming up with the idea. Well, we could also, if we're going to build a lab where we can test all these kind of products, we could also offer those testing capabilities to companies that might be able to use our facility to help innovate, to help make design decisions, and to help make their products better and safer and more sustainable and things like that. So we got some initial funding from our Colorado State Office of Economic Development and also the Outdoor Recreation Industry Office to help us really find our space, buy our initial equipment, and get things going. And so we built the lab at CU Denver. We are one of the University of Colorado system campuses. There are four of them. There's CU Boulder, which is really the state flagship campus, the Anschutz Medical Campus, which is about 20 minutes east of us here in Denver. There's a campus in Colorado Springs, and then also CU Denver, which is right in the heart of downtown Denver. It's about 15,000 students, primarily undergrad, but about 5,000 grad students. Within the College of Engineering, Design and Computing, we have 5 departments: bioengineering, civil engineering, computer science, electrical engineering, and mechanical engineering. And so the lab falls under mechanical engineering. Like I said, we partnered with Outside to create this. You've probably mostly heard of Outside. I think people in this field know who Outside is. They've really become a big presence, especially over the last several years. But huge creator of content, audience of 80 million people, and really gives us a good platform to get the word out about what we're doing, both from the reviewing products standpoint, the offerings to companies to help innovate their products, and then as well as our educational program that we've also built around the lab. And so the goal of the lab is to conduct product testing that can help increase outdoor participation by making the projects more comfortable, safer, and increasing accessibility and also sustainability. We've really gotten a big push for that over the first couple of years that we've been running here. And like I said, we want to offer that to consumers, to companies, but then also to our students here at CU Denver.
Great. So that's kind of the context around the lab and how we got started, and sort of what we intend to do with the space that we've been given. So where I would like to take it now is to talk a little bit about our current capabilities within the lab, as well as some of our future capabilities and test systems that are under development. Then I'll talk about some of the industry work that we've participated in thus far. I'll get into a little bit of discussion of our master's program and how we're looking at educating our students. And finally, I'll end with a couple of past student projects that we found particularly interesting or well done that have come through the lab. So with all that being said, the kind of most popular test system that we have in our lab is this machine that we're looking at here. This is the Time Machine made by a company called Helix. They're based out of Santa Barbara. They're considered one of the premier footwear testing facilities globally. To the best of our knowledge, only 4 of these systems exist in the world, or there are only 4 locations with this system. One is the company that makes it, one is the Nike World Headquarters, one is the New Balance World Headquarters, one is us. So we feel that we're in pretty good company when it comes to our capacity to evaluate footwear durability, which is what this machine has been designed to do. So if you look closely at it, what you'll see, it looks a little bit like a broken down treadmill with a swing arm rotating around it, and because it is. And so what we've done here is we've taken apart the treadmill and used that to offer a consistent speed of rotation of the footwear that we're testing. So we have 2 different speeds of tests. One of those will be a walking speed and one of those will be a running speed. All of the forces going back into the feet attached to this particular system have been calibrated through biomechanical analysis of the company that makes it. They've been calibrated at the moment based on a 50th percentile male. Approximately 180 pounds would be the equivalent there. And one of the things that we would like to do with this system is actually change our calibration so that we can offer both 50th percentile male and female weights as we're going through and testing. To elaborate a little bit more on what specifically we're looking at when we test on this particular system, we're looking at the tread of a given shoe as well as the midsole materials and how those are breaking down over time. So our testing protocol is to run or walk each of these shoes for 150 miles. We're taking measurements of things like midsole thickness, forefoot thickness, tread depth, as well as mass. And what we're using those pieces of information to define is how those various properties have broken down over time, which allows us to then compare how durable one shoe is compared to another. In this regard, we've done testing of hiking boots, hiking shoes, walking shoes, carbon-plated racing shoes, casual running shoes, and pretty much everything else that we can get our hands on. So this has been a highly versatile machine for us. It's been our most used machine in the lab in terms of number of hours running. And we also think that it's pretty good optically because most of the time people can get a pretty good sense of what it's doing just by looking at it. In addition to the Helix Time Machine for footwear durability, we have a few other tests that we've done to characterize mid and outsole materials of footwear. So on the left, we have just an example of our MTS test frame. This is a universal test system that allows us to do things like compression, tension, bending. We've done some peel testing with it. We can do cyclic loading, stress relaxation, and otherwise. And so what we're doing in this case is a variety of different mechanical tests on footwear in order to characterize the materials that ultimately go into the final product that you see. And so the picture on the right here is an example of where we might be measuring the stiffness of the foam stack right kind of at the midfoot location, right under the arch. We could also do this in a variety of different locations depending on how we set up our machine. Aside from footwear testing, we also participate in quite a bit of textile testing with various brands within the industry. So these are a couple of examples of ways that we can do textile testing. On the left, what we're looking at is the James Heel HydroView machine, which is a water permeability tester. More specifically, it is a water column test. And so what we're doing here is we're using pressurized air beneath a bed of water to try to push water up through the surface of a material from the outside of that material to the inside. The idea with that is we're looking at how well protected from, for example, rain or snow you might be with a given jacket or other piece of outerwear. So this water column test allows us to directly quantify your K rating. So if you've ever gone and gotten a new rain shell or a new ski jacket, you've likely looked on the tag and seen that it's maybe 10K waterproof, maybe 20K waterproof, maybe some other number that you've seen. So this machine allows us to go ahead and directly measure that. What we can do then is compare a given product to a manufacturer claim, or we can compare products against each other to determine what those failure points are and how they compare across different products or brands. On the right here, we have a fairly similar system. This is for testing air permeability. This is primarily beneficial for things like windbreakers, where you want to make sure you're stopping air from getting through. We've done a lot of testing on running shirts with this as well, where in that case, you want a lot of air to get through to keep you nice and cool. So in this machine, we lay a piece of material right over the top of it. It is essentially just a large vacuum that's going to pull vacuum down through that material at a known pressure differential. Then based on that known pressure differential and the size of the opening that we're pulling air through, we can determine how fast or how much air is moving through that material in a given amount of time. And again, we can use this to verify manufacturer claims or compare across products within a brand or across multiple brands to see what performs the best in this particular case. Moving on from those two, we have another textile testing system. This is probably our second most used machine in the lab. It is our James Heel Aquabrasion, which is a Martindale machine allowing us to test both wet and dry abrasion. This machine was advised to us to purchase through some folks that we've been in contact with at the North Face, given their positive experiences with this test system. We have also had some pretty good experiences using this test system to compare across different products what the level of abrasion resistance actually is. The really cool part about our machine that not all Martindale machines will have is that we have the capability to test abrasion both wet and dry. So all the little tubes you see coming off of this machine feed into a tank in the back that holds whatever fluid we put into it. So at the moment, we've primarily been doing water as our wet abradant. But what we've talked about doing is creating some sort of saline or synthetic sweat solution to better mimic how these products actually perform when you're outside working hard and you're really sweating in them, as well as doing things like sunscreen or oil or bug spray, other fluids that you might come into contact with in your various outdoor activities to really get a good understanding of how durable are these materials in these various pieces of outerwear that we test. Outside of outerwear, we've also adapted some of the tools with this machine so that we can evaluate abrasion resistance of footwear uppers. That's relatively new in the lab. We've kind of just started playing around with how we can do that effectively. But in general, this machine allows us to be fairly versatile in the things that we're testing. So outside of the textile space, we do have some additional test capability. The machine that we're looking at here is kind of our latest and greatest in the lab. It's something that we're really proud of. So this is our ski and snowboard tester. This was designed entirely in-house by our lab team. It was also built in Colorado by a gentleman just up the road from us near one of our favorite ski resorts. So it's really cool to us to have kind of done this all locally grown in Colorado. But what the intent of this machine is that we want to be able to quantify things like bending stiffness, torsion or edge engagement stiffness, camber profile, various side cut radii, and other geometric features of a given ski design. The reason for this, there are currently some groups out there, as I imagine many of you may be familiar with the Sooth Ski folks. They have a ski machine that is dedicated specifically to ski, aimed at doing something very similar to what it is we're doing here. Myself, I'm a snowboarder, so looking at their machine and seeing that it was only applicable to skis was unacceptable to me, as well as one of our other lab team members. So we decided that we would go through with the process of designing our own machine, adding some additional capability and flexibility to testing in ways that we felt directly replicated the use case of these products when you're actually riding them. The other impetus for this machine is that if you've ever gone out to buy new skis or a new snowboard, some people may give you a stiffness value on a 1 to 5 scale. Some may report it 1 to 10. Some may just say it's soft or it's stiff. And in general, these products are all going to be tested differently based on in-house methods that are available. So what we really wanted to do was help standardize some of this testing and reporting so that we could either help manufacturers better understand how design changes influence performance of a product, or better educate our consumers when they're going out to purchase their new products and they have a specific feel or performance in mind. We want to be able to guide them to a product or a group of products that might fit their needs in that case. So again, this one near and dear to our hearts. Very cool for us to have gone through this process of designing and building in-house. And as of, I believe, December of last year, we filed our international patent on this. So it seems to be, relatively unique and accepted within kind of the industry of our peers. So some of the additional capabilities that we have in the lab, we can do a backpack volume test. So what we've done with this is work with a lot of backpacking packs, your larger kind of, 20, 30, 40, 50 liter volume packs. And what we're doing is we're going through not just trying to verify what the total volume of these packs is, but we're also interested in understanding where that volume actually is within the pack. And what we've observed is that many people go out and they'll buy a pack. And let's say they bought a 50 liter pack. And what they generally believe is that 50 liters should all be kind of in your main compartment, that, the big main compartment of your pack. And what we're finding is that may not always be the case. In some cases, if you have 50 liters, you might have 30 in the main pack, an additional 20 kind of scattered around various side pockets, stretch pockets, mesh pockets, et cetera. So this allows us to really go through and get an understanding of not only what is the volume of this pack, but where does it sit? And hopefully we can help people better understand the products that they're interested in purchasing. Recently, we've also developed a breathability test. This one is fairly similar to air permeability, except that rather than using dry air, we're using moisture vapor. So the idea of breathability, rather than dry air from the outside of a material to the inside, what we're looking at is moist air from the inside of a material to the outside. And the analog there is how easy is it for the sweat when it evaporates to get away from your body and keep you cool as you're outside performing whatever activities it is that you're interested in. We also do some testing with headlamp performance, both for brightness, beam distance, and battery life. We do that at ambient temperatures and in cold environments, because we know that in cold environments, your battery performance is going to be significantly reduced. So we want to be able to quantify what is that reduction in performance based on the systems available to us. We have insulated beverage container performance. That's kind of a fun one that we usually will do in real time at various conferences and festivals we go to, because it's easy to kind of see what it's doing. And much like I have here, there's a variety of different products available on the market at a relatively affordable price that we can use as kind of our test samples to compare those sort of events. We also have a glove wettability. We've used this primarily in the snow glove space, where we want to see if at a certain point after being exposed to moisture, that moisture is then going to absorb into your gloves, maybe make your hands wet and cold and make you a little bit uncomfortable. As far as testing that we're aiming to do in the future, we have all sorts of different ideas that we would like to pursue. This is not an exhaustive list. We're always open to working with brands or individuals to come up with new testing methodologies or systems. But some of the ones that we currently have in progress are a weight distribution system for packs. So in general, most people, when they're backpacking, try to follow the 80-20 rule. So you want 80% of the weight at your hip belt and 20% on your shoulders. Using a system of flexible force sensors at various locations on the body, we can actually start to quantify where that weight sits on you as you wear a pack. And then we can add additional weight into it and start to see, with increased loading, does the weight distribution shift to other places on your body, and where kind of is that limit of the 80-20 rule. The next one on here, the shoe rocker profile system. This one was a project suggested to us by the folks at Helix that made our time machine. Specific to carbon-plated running shoes, what they're really interested in is understanding the curvature in the forefoot, both where it starts and how aggressive that curvature is. So we currently have one of our master's students working to develop a system of LiDAR sensors that can then go through and take point-wise measurements at any position along the surface of a shoe, and then give us information as far as what that shoe rocker actually looks like. Another student project that we're working on is some UPF testing and UPF quantification for various pieces of outerwear. We'd also like to build a drop tower for impact evaluation. Just as an aside, my PhD here is in impact attenuation of mechanics of polymer and lattice materials specific to helmet applications. So I have a great deal of experience doing impact testing, and I think that I see a lot of opportunity for us to do that in the outdoor space. And so we're going through at the moment and trying to revamp some of the impact testing capabilities that we previously had in these campus labs. Climbing rope durability is another set of tests that we're interested in. This one has been suggested to us from the folks at Outside and with their climb product group specifically. And so what they're really interested in is the sheath of your rope and how likely it is that that's going to be abraded against rock or other jagged objects. And finally, some of the other testing that we're developing is a vibration and damping evaluation system. I had spent some time playing around with this both for skis and snowboards as well as bike handlebars. And what we want to do with this is really start to understand when someone says their newest product is damp, what does that really mean and how might it be different from existing products on the market or previous products that they offer? So with all of these capabilities, there's a few different ways that you might be able to engage with us in the lab. So as Dana mentioned, part of the use or the utility in the lab is that we can support outside subjective user reviews with some more objective lab-based data. So in many cases, a lot of the testing that you'll see if you're to walk by the lab on a given day are myself or one of our other lab team members doing a bunch of different tests on various pieces of outdoor gear so that we can supplement the outside gear reviews. In addition, we have our educational program where we teach a master's in outdoor gear development to the various students within our program. And so you may also see, if you were to walk by the lab, a variety of different tests being conducted by students where they're really trying to dig into the technical side of our favorite products and start to better understand what features of those products are going to influence some sort of performance metric. And finally, kind of on the innovation side, we'll work directly with various gear companies to perform product testing or product research in whatever capacities they deem valuable to their organization. So that's kind of the synergy of the way our sort of three modes of operation work. In general, we're always testing gear. The real difference is what was kind of the motivation or where did this testing come from. So to give you an example of some of the things that we might do with industry, there's a company local to us here in Colorado. They're about 20 minutes north of us called Send It, and they make mountain bike tailgate pads as well as a variety of other mountain biking accessories. And they came to us looking to go from version 1 of their tailgate pad to version 2 and had a variety of different performance considerations that they wanted us to test on their version 1 and version 2 so that they could ensure that it was in fact stronger than the previous model. So some of the things we looked at with this are tear out strength of these top loops, right? So if you've ever used one of these products, you know that that top loop is what's going to secure your bike frame to that pad. So if that fails, there's potential that you're going to be in a whole lot of trouble and potentially in need of a new bike. So we want to make sure that this isn't going to rip out at a force far exceeding what you would experience just from having your bike on the back of your truck. We also looked at the strength of these various hooks here. These specific hooks are actually used to strap the entirety of the pad to your truck itself. So again, if these fail, significant issues, the pad may detach from your tailgate, and that's going to cause all sorts of problems for you. We also looked at the recovery of the foam. So if you leave your bike on the back of your truck for a few hours as you're riding out to where you're ultimately going to get on the trail, and you come back and put it back on your truck, has this foam recovered its shape such that it is going to absorb some of the impacts as intended, or has it not recovered its shape and now you're risking potential damage to various components of your bike, frame, tailgate, etc. And then we also did some abrasion resistance and strap strength testing for this product. Primarily, their concerns in most cases were strength, but they also wanted to ensure that as you have a bike sitting on here and you're riding down the highway to your local trail system, that your bike frame was not going to then abrade this pad and cause damage to the pad over the duration of its use. So to give you an example of what some of this might look like if we were to test in the lab, so for some of these hook strength tests, what we did is we tried to set this up in such a way that it was analogous to how this is actually going to fail when you use it. So in this case, what we did is we took that metal hook, we clamped it in the bottom of our MTS. We then took the strap that would actually be attached to that hook, anchoring it to your truck, and we attached that to the top grip on our machine. And then what we did is we just pulled those two clamps away from each other until the parts broke. So what you're looking at on the right here is a representative graph of force versus displacement for this particular material. So as we move those two clamps away from each other on this x-axis, we can see how much force it actually took to do so here on our y-axis. And then that allows us to determine what the failure point actually was for this particular product. So in that case, what we found ultimately was that this hook would fail in this particular location at a load that we had determined through our testing. So then what I did to make sure that our results were accurate and made sense within the realm of possibility is I conducted a finite element study. So I made a digital model or a CAD model of this same part on the right, subjected it to the same loading conditions that we did in our physical experiments, and then ran a simulation to determine under optimal conditions where should the failure occur. And so what we found in this case was the part failed where we should expect at the loads that we should expect. And so there were no sort of unforeseen defects or issues with the particular part that we were testing. Some of the other testing that we've done, specifically with brands, we've worked with folks like Big Agnes, the Colorado River Surfing Association, and Town Hall. So Big Agnes, you may be familiar with, they're up in northern Colorado. They make a lot of tents and camping accessories, and they had some products that they were under development on and interested in switching to a new material. And so they wanted us to quantify strength of that material. The Colorado River Surfing Association project was pretty interesting. They came to us and they were under development on a surf leash system that had a quick release. So the motivation for that, they had an increase in popularity of river surfing here in Colorado. And what they were finding was in some cases, if there's a lot of debris or branches or things hiding under the water, if a surfer went down, his leash may snag on that, and that individual may not be able to get back to the surface given how fast the water is moving and pushing them away from wherever their leash was stuck. And they ultimately observed a few fatalities as a result of this circumstance. And so what they came to us doing was looking at their quick release system, helping them understand what the actual force to release that quick release mechanism was, to try to ensure that it was in fact usable and effective, and hopefully would prevent some of these serious issues that may be observed when you're enjoying that sport. Town Hall is another group that we've worked with. They're also up in northern Colorado. They make durable outerwear specifically for children. And much like the other two groups, they came to us with some proposed innovation and they wanted to quantify performance around it. So we did a variety of different tests on some of their outerwear products in order to determine what the performance was, both with their previous model and with their new model. So to elaborate a little bit more on kind of the connection to outside and what that looks like. So I mentioned previously in conversations with Jamie, we've been filming a lot of different sort of how we test videos or little YouTube clips on what we're doing in the lab and why with the media team from outside. Those are starting to be published online. And I have the URL listed up here at outsideonline.com. The idea with that is we're not intending to keep any secrets from anyone. We're doing this as objectively as possible. And we want people to have a very concrete understanding of how we test product and why we test in a specific way. And we're always open to suggestion about, maybe there's improved methods we could use, alternative ways of doing different things. We're always open to conversations with individuals involved in the space as far as how we're doing it and are we doing it correctly. In addition to their videos, as Dana's mentioned, what we're trying to do with some of our lab testing is provide objective feedback to their subjective user reviews. So many of their best of articles that you could go online and find at the moment are actively being updated with objective lab-based data. So that if you're someone like myself who's a big gear nerd, you can really start to dig into the numbers on performance and see what that actually means, and maybe that helps influence your purchase decisions. In addition, being partnered with outside helps improve the volume and variety of testing that we're able to do. They have all sorts of connections to the outdoor industry, as you may imagine. So they've been a great help in helping us getting in touch with brands, figuring out what their needs are, and then bringing those tests into the lab and figuring out how we can help. In addition, because there's such a large volume of testing that we're doing both internally and with the outside folks, it also presents great opportunity for students to get involved and really hone their skills in product development, product testing, and understand what the data means when you pull it off of a machine. So with that being said, to elaborate a little bit more kind of on the master's program that we've developed here, as I mentioned, it's a master's program in outdoor gear development. And our intent is to establish Denver and specifically our campus as a hub for education and workforce development, where both our students and our faculty are able to collaborate with outside or with our industry partners and really start to conduct some real world product testing and understand how lab data may then correlate with some of the subjective user data. And so far, we've been able to work with a handful of different folks in the industry and get students involved in their projects. They've been particularly pleased with how well the process has gone. In addition, we've also been fortunate that a few of our students have now been hired into some of these roles and are working at places like Big Agnes, Lululemon, and the North Face, with some additional students in the interview process for some other outdoor gear brands. So finally, to talk a little bit more specifically about what our students might be doing when they come to our program, there's a variety of different ways that they can get involved with lab testing, but these are examples of a couple of different research projects that our students have put out in the recent past. So last semester, I taught a laboratory gear testing class where myself and about 20 different students go through and use all the different machines that we have in the lab to test all sorts of different products, giving them both experience in using the machines, but then pulling raw data off of a machine and understanding how to get that into a usable fashion. So this study I found to be particularly interesting. This group of students looked at the correlation between durability and sustainability of technical rain shells. So what they did was they called in a handful of products from a variety of different manufacturers. That was actually done through our connections with outside. They were able to get in touch with these brands and get some products sent over this way. So a big thank you to them for acquiring materials for us. And then we did some material testing. So we did air permeability and water permeability testing to see if that was going to keep you warm in a windy situation or if that jacket might keep you dry in a wet environment. Then what we did was we subjected all of these coats to abrasion. So we did 50,000 cycles of abrasion with the goal of essentially deteriorating performance, removing that DWR, potentially damaging some of the outer fiber layers. And then we retested our air and water permeability to see how well that particular garment held up to abrasion. Then the sustainability assessment. This piece was particularly interesting to us. We had a student in my class over the spring that was focused on sustainable business, and that was her master's program. So she really did a deep dive into various sustainability and emissions reports of the brands from which we acquire these various products, and then went through the process of figuring out how someone's rating on sustainability might correlate to their rating on performance or durability. And so what we did in that case is we compared sort of across the suite of products that we tested. And what we were trying to determine was whether or not increasing your sustainability efforts within a given product ultimately had an influence on its final performance. Another project that we just had completed at the end of last semester is also particularly interesting to us, especially considering that we now have our ski tester in the lab. So we had a student going through looking at the effect of core thickness and fiberglass layer separation. The idea is that we wanted to simulate a variety of different thicknesses of ski cores. So we used 3 different thicknesses. We laminated each of those materials with 2 layers of fiberglass, similar to what you might find in your typical traditional ski construction. We then did a 3-point bend test of each of these materials that we had made, which allowed us to compare the bending stiffness between them and ultimately find what the influence of that core thickness of the material was. So in both of these cases, what typically the way this works is we'll set out with kind of a general research question or an avenue or area that we believe would be valuable to pursue additional work. The students will come back to us with some proposed ideas. We'll work with them to kind of refine to some sort of finalized idea. And then they're responsible for going through, making all of their samples, running all of their tests, analyzing their data, and then writing a report so that we can better understand ultimately the results of their research. So with that being said, that is the outside lab at CU Denver in a nutshell, and we're happy to field any questions you may have.
So interesting. Thank you both. So we're in Zoom webinar, which means if you have a question, there is an option along the lower bottom to raise your hand. So you can click that button to raise your Zoom hand, and then I can unmute you and you can speak.
Hey, great presentation. My name's Chris Stone. I work as a designer up at Durston, up in the Kootenays. And previously I was at the North Face, so I've spent some time in their testing lab as well. But I have a question. So I teach in the University of Oregon sports product design program. And I know Utah State has an awesome outdoor gear design program. And I was wondering if you ever partner with or have any interest in partnering with these design programs to do testing. We have a lot of, at the University of Oregon, a lot of master's students who design awesome gear, but often have to put together fairly rudimentary tests to test that gear.
Yeah, I think being a university, the academic collaboration is something that we've talked about. We also have up north in Fort Collins at Colorado State, I believe they have a textile design program. So we've talked about the idea of collaborating either somehow more programmatically, or if it was just a need for a space to test some of the products that have been developed by students, we're open to what that looks like. We're not particular on whether that comes from Oregon or Utah or Colorado or Canada, et cetera. So we're definitely open to the possibility. And if you had more specific questions, we'd be happy to talk about what ideas you might have and how we can potentially support.
Awesome.
Yeah, 100%. Yeah. And just to kind of, I don't know, piggyback off what Trevor said, both of the programs that you've mentioned, so both Oregon and Utah State, we've over the last couple of years had talked to people that, whether it was for, at one time was just a person at the outside festival last year, we had a tent set up. Or 2 years ago, I guess first one. But I talked to another person that teaches for that Oregon program, 3D garment design, and then and then with Utah State, I've talked with a couple people over there as well. I tried to get a visit there organized last year that we ended up being able to make it happen, but definitely open to that. I mean, I think we're more on the engineering side. We're doing product development as part of within our engineering program. But would love to collaborate with people that are more on the design side, industrial design, product design. I feel like we've both got a lot to offer each other. So would definitely be happy to talk more about that.
Cool. Yeah, we just a few weeks ago had a student defend her thesis, which was looking at snowboard flexibility. So your rig
Oh,
that you
cool.
talked about would have been perfect.
Yeah,
But yeah,
nice.
awesome. I think I already have your contact info, so
Okay,
might be in
cool.
touch. Thank you.
Yep,
Yeah,
thank
and if
you.
you don't, I can definitely connect you.
Awesome. Thanks, Jamie.
You're welcome. Thank you. I've got another question here.
Yep.
Rocio.
Hello, everyone. My name is Rocio, and I'm actually the founder of a new organization based out of New Mexico. It's called Escalera Academy, and it's a STEM outdoor education program with a focus on what makes rec possible. And so, right now, I'm in communication with your Boulder campus, actually. Um, and so, I had an interest to see if you may have a few students that would be interested in either sharing their own research or even doing workshop with some students. The goal is to introduce students to alternative STEM career paths that they have not been introduced to in this community, being that there's a heavy emphasis on LANL in these parts. But there is a robust, like outdoor rec landscape here. So I just wanted to hear your thoughts if that was something that maybe your faculty or maybe some students would be interested in internship opportunities or something like that.
Yeah, I think that's definitely something that we'd be interested in supporting. And it sounds like you're already in discussions with the folks at Boulder, so we're in the same, system. I think it would be easy enough for us to also get involved. But I think in general, when it comes to, collaboration, we as a lab are very open to academic collaboration, to industry collaboration, or otherwise. So if there is a way that we can be of some sort of help to your organization and help maybe show your students some alternative paths, feel free to send us a message so that we can get the conversation started. We're happy to look into how we might be able to help you.
Yeah, that would be wonderful. I actually had no idea that Denver had this, and so I wanted to hop on and learn more. And I think, yeah, some students would be really intrigued to learn that there are alternate engineering paths that they can take. So
Yeah,
that would be
100%. I'd say, yeah, reach out to us. Um, yeah, like Trevor said, we're open to collaboration we put in all the effort to build this lab and we want it to be used and we want it to serve a good purpose and to help as many people as we can. So definitely reach out to us.
Yeah. Another
awesome.
thing I
Glad
will
to hear
just
it.
add, oh, sorry, go ahead.
Oh, I was just going to say, glad to hear it. Thank you.
Yeah. Another thing I wanted to add regarding our program that is relatively unique within the space, at least as far as we're aware, is that we don't require you to be an engineer in undergrad in order to join our program. So we are run through the mechanical engineering department. Our last graduating cohort, actually our most outstanding student from the department in that graduating class, had a background in graphic design, and now he's working as a product specialist up at Big Agnes. So you can absolutely come to us without being an engineer by trade and be successful. All we ask is that you have a willingness to learn some of the kind of engineering basics that you'll need in order to understand the tests that we're doing. But we have our program, as open as possible to all sorts of different backgrounds because we believe that those differing perspectives are only going to help drive innovation forward and help us find new ways of doing things within the lab.
Yeah, that's really wonderful to hear. I was a musician for many years and went to college for music, but then have my master's in recreation out of SUNY Cortland.
Mhm.
So that's pretty amazing and looking forward to having the opportunity to learn more about your students. That's great to hear. Thank you.
Yep, absolutely.
I see a question from Josiah. You can go ahead.
Hi, yeah. So I'm a product design student, and I was just wondering what's the best way to reach out to, like I'm doing my capstone next year, and if I wanted to reach out to talk about doing testing with you guys, what
Mhm.
would be the best way?
Yeah, so if you went online and searched up the outside lab, it should one of the top two links should be a link to our contact us page. On there, you'll find a little submission form that asks for, I think, your name, email, phone, and a brief description of what you're interested in. That if you fill out that contact us form, that goes directly to my inbox that I monitor daily. So I can go ahead and get back to you on there. If you're unable to find the page, the actual email address is just outsidelab@ucdenver.edu. So you could email that directly. That is the same email inbox that the contact us page goes to. And again, I monitor it daily, so I'll be able to get back to you with some answers.
Okay, amazing. Thank you so much.
Yep.
All right, well, I think we're through then. Thank you so much, Dana and Trevor. Is there any questions that either of you wanted to ask to the community before we go?
I don't know that I had anything specific to ask, but I just wanted to say thank you very much for having us and giving us an opportunity to present on what we're doing and what we're working on and how other people can get involved with us. I think there's a lot of synergy between what y'all are working on and the things that we do. So if any of you out there have ideas or things that you want to suggest to us that we should get involved in, please let us know. And we're happy to start looking more into it and start those conversations. But thank you again for letting us participate today.
Yeah, thanks, and thank you to all of you that were on here and listening and asking questions. Definitely reach out to us, and then if those of you that watch this later in a recording, we're just as happy to answer your questions too. Just send them our way, and we'll be happy to get back to you.
Amazing. Thank you both. Before I sign us off, I wanted to mention that early bird registration is open for the annual Core Outdoors Summit. The summit is Canada's only conference dedicated to the outdoor gear industry, and it's open to professionals, aspiring professionals, academics, students. Everyone is welcome. It's September 17th through 18th this year, and it's held, as always, at the Kimberley Alpine Resort in beautiful Kimberley, British Columbia, Canada. You can find details and registration information on the Core website. Just to mention, early bird pricing only goes until June 30th, so don't delay. All right, it's a wrap. I'll see everyone next month. I'm signing us off. Thank you.